Hey everybody, welcome back to Math Pastor. Hey, in this series of factors, fractions, and exponents, we've talked about factors, we've talked about fractions, and today we begin talking about exponents. This section is rules of exponents. Alright, so today I want to actually explain a concept using numerical examples, and then I'll move to a generic or general example of that rule. So first, let's look at this example. If I have 2 to the third power, and I have 2 to the second power, and I'm multiplying them, what I end up with is 2 to the third power is simply 2 times 2 times 2, and 2 to the second power is just 2 times 2. So if I'm multiplying these 3 2's to these 2 2's, I end up with 5 2's being multiplied together. In other words, 2 to the third power times 2 to the second power becomes 2 to the fifth power. All right, so there's one numerical example. 2 to the third times 2 to the second equals 2 to the fifth. All right, let's look at one more example to help solidify this mathematical concept. If I have 8 to the 8th and I'm multiplying it to 8 to the 5th, then I have 8 8's being multiplied to 5 8's. So 8 times 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 8, that's the first term. And then 8 times 8 times 8 times 8 times 8, that's the second term. I have 8 8's being multiplied with 5 8's, so in total I have 13 8's being multiplied together. Let's look at that one more time. 8 to the 8th times 8 to the 5th becomes 8 to the 13th power. All right, look at these two examples for a moment. It looks, and actually it is, that the exponents add together to get the answer. So 2 to the third times 2 to the second becomes 2 to the fifth because 3 plus 2 is 5. And 8 to the 8th times 8 to the fifth becomes 8 to the 13th because 8 plus 5 is 13. So in a very real way, all we're doing when we multiply numbers that have the same base is add the exponents. So what's the rule look like? Well, this rule is called the product of powers property, or sometimes it's the product of exponents property. But either way, however you say it, here's what it says. When you multiply two numbers with the same base, just add the exponents. So a to the m power, any number to any power, times a to the n power, same base, different exponent, just becomes a raised to the m plus n power. So the rule is this. If the bases are the same, simply add the exponent. All right, well, one of the great things about math, or maybe the worst things about math, depending on your perspective, is that anything you can do one way, you can do backwards. And we can do the same thing with the powers of exponents. So we just talked about the product property of powers or exponents. So we can multiply exponents and add the exponents, but we can also divide exponents, and that means we would subtract the exponents. Here's a couple examples. If I had 3 to the 6th power, and I was dividing it by 3 to the 3rd power, I could write that straight across, or I could write it as a fraction. Remember, fraction is just a division problem. So if I had 3 to the 6th power as my numerator and 3 to the 3rd power as my denominator, what that really means is I have 6 3's being multiplied on top and 3 3's being multiplied on the bottom. So anytime I have a factor that's common to the numerator and denominator, I can reduce it out. So if I expand these, what I see is that 3 3's reduce out, leaving 3 3's in the numerator. So 3 3's in the numerator 3 to the 6th power divided by 3 to the 3rd power reduces to 3 to the 3rd power. So in a very real way, 6 minus 3 is 3, and those are just the exponents subtracted. All right, let's look at this next example. If I had x to the 7th divided by x to the 3rd, that means it's a fraction where x to the 7th is the numerator and x to the 4th is the denominator, and I expand them so the top becomes x times x times x times x times x times x times x, 7 x's multiplied together, and the bottom becomes 4 x's multiplied together, then what I can see is that 4 of those x's will reduce out. So this one, this one, this one, and this one. So now I have 3 x's left in the numerator. So x to the 7th divided by x to the 4th is simply x to the 3rd. Or, look at the exponents. 7 minus 4 is x to the 3rd. All right, so what's the rule? Well, this is the quotient property of powers, or quotient of powers property, however you want to say it. Ultimately, here's what it says. If you have two numbers with the same base and different exponents, and you're dividing them, simply subtract the exponents. In other words, any number a to the m power divided by any number a to the n power, so we have the same bases, simply becomes a to the m minus n power. And there you have it. There's the two properties in this section. All right, guys, hey, we're going to close doing one example that shows both these properties together so we can see how they work. All right, here it is. Now, brace yourself because it's going to look like a monster problem, but as we'll see, it's pretty simple. Check this out. We have 5x to the 4th power times 2x to the 5th power, all divided by 20x to the 2nd power. All right, so in the numerator, we're going to use the product property of powers to put these together first. So look at the numerator. Well, 5 times 2 is easy. That's going to be 10. And then x to the 4th times x to the 5th, 4 plus 5 is 9, so that all becomes x to the 9th. So the numerator becomes 10x to the 9th. So now our problem is 10x to the 9th divided by 20x to the 2nd power. Now first, let's reduce the numbers. 10 goes into 10 once, and 10 goes into 20 twice. So 10 over 20 becomes 1 over 2. That's more simple. And then x to the 9th divided by x to the 2nd, 9 minus 2 is just 7. So x to the 9th divided by x squared becomes x to the 7th power. So what we have here, the whole thing becomes 1/2 x to the 7th. So remember, when you do these, you might see multiple steps in one problem. Just keep them separate. Do everything in the numerator. Do anything in the denominator you have to do. Use the product property. Use the quotient property. Do them all separate, and you get to your final answer, just like we did with this example. Hey, you should be ready to tackle any homework problem you see when it comes to adding or subtracting exponents because you're multiplying or dividing them. Good luck.